Together yet. My name is Christopher Benage. I am a developer for the Patterns and Practices team. Been in the position a little less than 2 years now. Most of my time at Microsoft has actually been focused on JavaScript. Today I'm going to talk to you specifically about my experiences with HTML5, CSS, JavaScript, and Windows 8 in particular. The format I want to take with this talk actually is not so much to give you everything you need to know to build a Windows 8 app with JavaScript, but rather some of the insights that I've gained from my development efforts that may not be apparent to you. Things that surprise me, either for good or ill. I'm easy to find on the internet. This is my name. It's also my Twitter address. It's also my blog. Now, following the theme of exploration that we've mentioned a handful of times, and also borrowing from the language you've heard in earlier talks, I went on a bit of a journey. And this journey was, as I said before, into JavaScript and the world of Windows 8. And what I found there was there are things both beautiful and strange, terrifying and exhilarating. And for me, it was a bit of a wonderland. So my theme for today's talk is my journey into this wonderland of Windows 8. And much like Alice, when she followed the rabbit, she encountered things small and things large. Some of the tips I'm going to provide you with today are about little things I come across, or they're going to be about large things that I ran into. So the first thing I want to do is give you a little bit of an overview about the world of Windows 8 development for JavaScript applications. And one thing I've found is that even though we've been talking about Windows 8 for quite some time now, I've encountered a lot of developers who don't really understand that when you're building these Windows Store applications, which, by the way, that is the official title, they do run into Sandbox. And this crowd has probably picked it up by now, but I think it's an important point to drive home that you don't get the full functionality you get from traditional development environments, right? You can't do everything in a Windows Store app that you could do in a WPF app. And this is generally, the developers don't like power taken away from them, right? We like more power being given to us. But I think this is actually a really, really good thing. It's analogous to a restaurant that makes one dish that makes it really well, as opposed to the buffet that's okay, it's kind of good, you can get it whatever you want, but the experience isn't the same. And one of the things about Windows 8 that I want to say up front is that when you are building apps for Windows 8, you need to care about the experience, because that's what matters in today's market. A second major point at the beginning I want to say is that you really need to understand the life cycle of Windows Store applications. Now, I don't want to go into a lot of detail here at this point because I said before I want to give you the things that tripped me up. This is something you can read about in the documentation. Francis talked about it as well. But this is an important concept to understand that's going to underlie all of your Windows 8 development. So look up the life cycle, understand it. Just to briefly, well, actually not even briefly. That's all I'm going to say about that. Okay. So now I'm getting a little bit more to the meat of what I want to talk about. There is a landscape here for development. And as we make our journey through it, there were different sections and nations and countries that I ran into. Now, the first part is the Windows runtime, and you've heard a lot about that today, and that is the core APIs that exist across all of Windows 8 development efforts, right? You get that if you're using C++, you get that if you're using C#, and you get that in the world of JavaScript. On top of that, there's also something else called the Windows Library for JavaScript, which you'll also hearing us refer to occasionally, unofficially, as WinJS. And this is actually a pure JavaScript library that you add through Visual Studio the same way you might add an assembly reference to a .NET application. Right-click and say Add Reference. But it's actually a set of JavaScript files that's linked in there. And I found that there's a little bit of blur in my mind when I access these APIs. Sometimes I don't realize that I'm going to Windows versus the Windows library for JavaScript. But I think it's important to understand the distinction of what you're getting. So as we walk through the rest of this talk, that'll be something I'll point out to us. In addition to that, there are other just APIs that are available to you, such as the DOM. Right? Now, the DOM itself isn't part of the Windows runtime. It's not part of the Windows library for JavaScript. It's what you get for interacting with the graphics subsystem. On top of that, maybe not on top of that, but next to it is JavaScript itself, which has a whole host of APIs for doing all kinds of things, like IndexedDB, for example. And those are, again, not part of any of these other layers. And one other thing that we're going to talk about as well is that when you go to Visual Studio and you say File, New Project for a Windows 8 JavaScript application, you're going to get some code there that is not part of any of these, but is also an additional set of JavaScript to use for building your Windows Store applications. Make sure I covered everything in my notes there. Okay, so I want to, with the rest of this talk, dive into 3 areas. And the first area is the fascinating and mesmerizing world of JavaScript. Now, I'm curious, how many of you consider yourself JavaScript developers? Right. Not very many. How many of you consider yourself familiar with JavaScript? Okay, that's good. I was one of those jQuery devs until about 3 years ago, and then I started diving in deep into it. This is my trinity of books I recommend to anyone who's learning JavaScript, or even if you think you already know JavaScript. The first book is Douglas Crockford, who everyone has heard of probably at this point, called The Good Parts. If you're not familiar with it, I highly recommend it. But it's also one of those things for me that once I learned it, once I understood the rules, I chose to break a few of them. So I don't give it to you as gospel, but I do think it's definitely worth your read. The second book I highly recommend to all JavaScript developers is this JavaScript Patterns book, which probably for me was the most profitable because the first book, Crockford explains to you sort of where the traps are. What are problems with the language that will lead you into dark and terrible places? The second book, though, is really about overcoming some of the limitations of the language itself, right? What are some patterns that you can use in building JavaScript-based applications that are at a higher level? And the last book by Nicholas Sakis is about performance, which I really wasn't that interested in until I started working with Windows 8. Because the sort of applications I was building is changing. And I think this is true for the JavaScript world in general right now, right? As we have a shift in focus toward these single-page applications, we're doing more and more. As Scott emphasized in his talk, there's so much you can do in the browser now, which means that performance matters more there. I've also been dipping my feet into HTML5 game development, where performance is important. And there's a lot of amazing things you can pick up from this book. So that's my 3 major recommendations. Okay, so when you're working with JavaScript, there are lots of strange things that affect the responsiveness of your app. So for those of you who aren't too familiar with JavaScript, one of the important things to realize with it is that it is a single-threaded environment. And what that means is that everything runs in the UI thread. There isn't a background thread, really. Now, if you know a lot about what's going on in the space, you may say, well, there's web workers, and they're kind of like background threads, and that's true. But for most intents and purposes, everything you do is going to block the the UI thread. For the majority of JavaScript developers, this doesn't really matter much because we don't do a lot of expensive calculations in JavaScript, so therefore the code we're running doesn't block it for very long, and in fact it's not really noticeable in most situations. I forgot to cite the source for this, but I believe any pause that's under like 150 milliseconds, most users don't perceive. When it gets to be beyond that point, that's when we start recognizing it. But there were a few scenarios I ran into where I was surprised at what blocked the UI when building a Windows Store application with JavaScript. So let me give you a little bit of code. And I know that's small, so let's make it nicer. Oh, that's not what I expected, right? Because I'm on 2 monitors. Can I do this? What I get there. Okay, let me fix it this way, guys. Duplicate. This is the part where like Scott would tell a funny joke, but imagine Scott telling a joke here. Okay. And I'll imagine you laughing, right? There we go. I just want to show a code sample. It's not hard, right? Okay. Apparently I don't understand how to use a computer. Third time will be the charm. Here we go. Do this. I will do this. Oh, I'll fail. What's that keystroke for jumping straight to a slide? How about that big button at the top that says from current slide? Yeah. There we go. Okay, this is all I wanted, although just a little bit to the side. Okay, so here is some fictitious JavaScript. Oh, I need a little more room than that. There we go. Okay, how's that for woo! Success, thank you. Actually, I'm done. I'm going to leave on a high note. Okay, so let's imagine that we have some function that's going to acquire for us a large array of items, thousands of items or whatever. Actually, in my scenario that I really did this with, it was only, I think, a couple hundred items. And then we have some other function, some sort of operation we want to perform in each one of these items. But it's an expensive calculation. Okay, so it's something that is a synchronous operation. It's executing the UI thread that takes some time. In this scenario, the UI would be blocked, right? And in fact, when I say the UI is blocked, things like hover effects that are based in CSS, mousing over a button, you don't even get the effect. The UI thread is completely frozen solid in this sort of scenario here. So what I wanted to do was to take this scenario and move, and let's hope it fits on the screen, change it to this. So, and this is something I stole from that high-performance JavaScript book almost entirely. So here we have the same sort of idea, but this does not block because of this little bit of magic right here. So same idea. We're getting an array of items. We're going to loop over it, but instead of using a traditional for each loop, we know, you know, there's one line missing you can't see. Oh, does she? I forgot I have to use the mouse. There we go. It's kind of important. That kicks off the process. So what we do is we say, okay, we want to iterate over these items. We want to do something expensive, but instead of having a for each loop, we want to do one item at a time, and then we want to tell JavaScript to let go, yield execution back to the UI so that it can do its updates, and then when you're ready, we'll process the next item. So the way we can do that is we can create an inline function right here. That's what this function process next is. And inside that, we actually do our expensive operation on a single item. Then we increment or decrement our counter in this case. And why do we do that, actually? Why do we do that instead of incrementing it? Because every time we call items length, it'll move over the array. So we want to just grab the count once right here. So then we decrement. And then if we still have items, if we haven't hit the bottom of the array yet, then we're going to go ahead and set immediate, which is a built-in JavaScript function. When I was giving those layers earlier, the WinRT, Windows.js, WinJS, this is actually part of JavaScript. And then we're going to say, hey, when you can, call process next again, and it's going to go through. Since this function is in line here, it captures this variable inside a closure, and that's how it maintains its state. Then we kick off the whole process by calling process next. So this does the same thing as the last bit of code I showed you, except for that it is yielding execution back to the UI thread. And then a little bit later in the talk, I'll get to a more complicated example. Now, one thing I want to say about this, though, in particular, is that even if you're a veteran JavaScript developer, you probably haven't seen setImmediate, and that is because setImmediate is actually an IE 10 specific API. You can accomplish the same thing with general JavaScript in that using that vanilla JS framework that Scott talked about, using set timeout with a value of 0. This is just a little bit more explicit in its intent, and if you're building Windows 8 applications, there's no reason not to use it. So now let's see if I can get back to the actual world of my slide deck. Okay. So my next little episode in my journey through the wonderland of JavaScript and Windows 8 was coming across the bind function. And this is actually a standard JavaScript feature, but it kind of trips people up a little bit. So bind uses the idea from functional programming called partial application. And if you haven't heard that term, I'm not going to dwell too much on it. Go look it up. Actually, on my blog, I have some articles about this. But what you need to know is that bind is a function that allows you to take another function, bind it to some parameters, and then you get a new function. So let's walk through what that really means, because I think that's a little bit confusing. Let's say we have a function. My pointer's, oh, there we are, called add, right? And it takes two numbers, right? And it's really simple. It adds those two numbers together. Now, let's say that we're going to be adding the number 7 a lot. We know that we're going to add 7 over and over and over and over again. What we can do with this built-in bind function is we can say, okay, add here is the name of our function. In JavaScript, functions are first-class objects. I can then call bind on my add function as an object. This is going to return to me a new function, which I'm going to call add7. I'm going to provide it with 2 parameters. The first parameter is null. I'll talk about that in a minute. But the second parameter is 7. So what that means, what's that equivalent to, is actually as if I pass 7 in as x, and I have a new function that's going to be equal to, this is always going to return 7 plus y. So now down here below, I can say add 7, passing in a parameter of 3, and that's going to return to me a value of 10. You may be thinking, wow, that's really arcane, and how is that at all valuable? Turns out we use this a lot when we built these applications in Windows 8. Oh, I almost forgot my third point. This will become important in a minute, so if it doesn't make sense, we'll talk about it more. But the first argument that I pass in as null is what resolves to the this keyword inside the function. This particular function doesn't use the this keyword, so it doesn't matter what I pass in. I'll give an example of that in a minute that will provide some more clarity there. So here is an example. Looks like we need to zoom in, I think, again. Fingers crossed. Oh, forget I have to use the mouse. There we go. Okay, we'll scroll up and down with this. So this is an example that is based off of some real code that we had in a Windows 8 application. I stripped it down to its bare essentials in order to communicate the real problem that we ran into. And this is why we ended up using bind in lots of places. So we have some object right here, right? And in JavaScript, in case you're not familiar with this, you can actually just declare an object as a literal on the fly. So I have some object I'm declaring, and I have 3, hello mouse, there we go. I have 3 properties on it. So my first property is some number, which is just a value that we have there. My second property is this function add, similar to what I showed you before, the inline function, except for in this case, I'm going to always be adding the sum number value to 1, and I'm grabbing some number from this. So that's going to resolve back to this value here. Okay? I feel silly saying this so many times when I'm giving these talks. This resolves to this. However, we have a scenario where if we have a function like this problem function here, and it does something async, and we pass into it a callback, and that callback points to this function here in this object, when this function is actually invoked in this scenario, then this won't work. It'll fail. See, I said this too many times again. So the implementation for my fake pretend to be async, you can see does nothing except for actually call the function and spit out the value to console. So to prove that this is a real problem, let's take this. I'm going to flip over to nothing. There we go. Okay. So I'm running Node. For those of you who are not familiar with Node, Node is really just JavaScript on the server, the console. So I just took that code that was in the presentation. I'm going to paste it into here. So now we actually have an environment where this object exists, right? And if I were to say something like some object dot, well, first let's do this, dot some number. We see there's the value 10. If I say some object and I call add, then it adds to it, which is what we expect. So if we call the sum function, however, pardon me, if we call the problem function, we'll see that we get a number is not defined. So the reason for this is, again, I can't get away from the word this. The reason for this is that right here, JavaScript is unable to resolve this to the object itself. But when we use the bind keyword, we can explicitly tell it that this is what we want this resolving to. Boy, that's horrible to say. So let me show you. What am I doing? Back to here. oh, I don't have that code example. So let's fix it in line. The solution would be, in this case, we could actually say that some object.add, here, we could call bind on it, and then we could bind it to some object. And that is going to return to us a brand new function, which I'm not going to name right now. Thank you. And now this X is actually a function itself that we can invoke, and it's always going to have the correct context. So in some of the code in our project, which I forgot to tell you the name of, it's the Hilo JS project or Hilo JavaScript project, we end up using this bind all over the place because when you do Windows 8, you do lots of asynchronous work. That's the way all the WinRT APIs work. And you'll end up losing this context. And this is a solution for getting around that. So now I will continue. So another question I've been asked when I talk about doing the Windows 8 work was, did I miss jQuery? And I really wish I had known about the Vanilla JS framework ahead of time because that was an awesome example of this. The answer is no, I haven't missed jQuery when I have been doing Windows 8. Now, I think jQuery is awesome. I'm not dissing jQuery. But for me personally, when I was using jQuery, one of the main problems it solved was cross-browser compatibility. And guess what? In Windows 8, there isn't really a cross-browser issue, right? I'm working all in the Windows 8 environment, which is essentially IE 10. One of the primary tasks I would do with jQuery was finding elements in the DOM. And guess what? There is a native way to do that. And this is a completely standards-based way to do it. Document.querySelector. There's also an additional method, the querySelectorAll. And those work a lot like the selectors that are inside jQuery. So I use those, and I never really missed jQuery because of that. Now, there are a few things it doesn't do, like pseudo selectors, if you like using those in jQuery. But it did 95% of what I needed to do. In addition to that, there are a few helper methods that are present in the Windows library for JavaScript, which you can identify because of the WinJS here. And they really plug some of the holes, smooth over some of the rough edges that you might miss if you don't have jQuery. Now, I think it's important to say here, though, too, that you don't have to use those WinJS libraries. If you love jQuery and that's the way you think, or if you love some other JavaScript library and that's the way you think, you can use it. You can use those libraries. That's perfectly acceptable. The only place where you might really want to use some of the WinJS libraries, if you have other favorites, is in the area of some of the controls, because there's some of the controls that are just large things that are difficult to implement on your own, and they don't exist in any other sort of library. They really embody parts of the Windows personality, such as those large lists that you can swipe back and forth. And those live in WinJS as well. So another problem I think that a lot of JavaScript developers don't often have to think about is memory leaks. And this has to do with the fact that most JavaScript that we've written over the last 17 years doesn't live for very long, right? We're constantly moving between new pages. Every time you change a page in a browser, everything's reset. The state is lost. However, in this new world we live in, of both single-page applications and Windows 8 apps, Windows Store apps, apps are running for longer. So there is much more of a chance for there to be memory leaks. And there's some of the same problems you might run into in building a single-page application. So one thing that everyone looks for, right, is event handlers that are unwired. But one that caught us off guard that I think is worth mentioning is this URL create object URLs. So this is a native API that's just part of the JavaScript APIs. And what it does is it can take a blob object. In our case, it was a file from the file system. And then it gives you a URL or URI that you can then use to attach to an image. So in HTML5, right, you want to display an image. You probably are going to use an image tag, although there are some quirks around that. You need some URL to set the source of that, and this is how you get that. If you have a JPEG on the file system, you have to call this function to get it. Well, what we found, unwittingly, was that this guy, every time you call it, it's going to allocate some memory for that. That doesn't go away. it stays there. Now, there is a sister API for revoking the memory, and you can pass it in the URL and it will go away. But if you don't call it, then, and in our case, we were looking at hundreds of images, the memory was just skyrocketing, and we didn't realize it. One other nuance about it is that if you use these URIs with an image tag setting the source property, the system will actually automatically pick it up for you and know to dispose of that. In our case, we actually were using div tags and setting the image as the background via this, and it wasn't being picked up, and we had some massive memory leaks that we had to go back through and clean up after the fact. So that was a handful of episodes and tips that I ran into with respect to JavaScript in general. So now I want to go into the world of the Windows library for JavaScript, WinJS, and talk about a few things I learned there along the way. So I'm assuming most of you were present for Christovaris' talk on asynchronous programming. So I'm not going to go too deep into this, but promises are really important. Understanding what promises are, it's a really important concept for building Windows 8 applications with JavaScript. So 3 things about them that I think are worth repeating. First of all, it is an object, right? It's an object that represents this task. The task may be fulfilled at some point in the future, it may be fulfilled immediately, but it is an object itself, which I actually, the more I think about it, I think that the word promise is actually one of the best named objects there is, because it really is a promise. Here's this thing I'm going to give to you later. The other thing that I just adore about them is how composable they are. The fact that I can chain them together, the fact that I can have a number of them running in series or parallel, that's amazing. The third thing that's cool, but I didn't think about enough ahead of time, is that they are counselable, which means if you have a long-running process that's taking some time, you can stop it and say, hey, I'm done. Now, what that means is actually up to how the promise itself was implemented. So most of the promises that would be yielded from things that originate with Windows runtime or WinJS are counselable. If you create your own, though, you may need to implement that logic yourself. Which brings me to my next point. When you have async operations, be sure to cancel them when you abandon that part of the UI. So the most common scenario I'm talking about is when you navigate away from a page. This was actually a source of bugs for us that we didn't realize until we were near the end of our development cycle, which is that we would do things like, hey, give me a bunch of images from the file system. But if the person at the back button right after we started loading up these files, we weren't canceling those requests. So you need to be aware of what your application is doing with respect to these asynchronous calls, because those asynchronous calls are core to making your apps responsive. But you're probably going to have to handle it more manually when it comes to counseling these things. We also had a scenario where we had a custom promise that we wrote ourselves that needed to be canceled, and that was logic we had to write. And one thing that Christovaris told me with respect to custom promises was that you probably don't need them, and if you do have them in your code, it's very likely a smell, so always really question that. If you end up finding that, you want to write one. But if you do write one, be aware of what it's doing so you can cancel it if need be. So here is a scenario that you'll see a lot in Windows 8. Oops, there we go. Oh, there we go. Okay, so this is a pattern that's all over Windows 8 applications. The idea behind this is that we're using this WinJS built-in API to define a page. And a page in the world of WinJS is really some sort of control that represents something you're navigating to. And you can give it a name here. Usually it's in the form of a URI, but the little secret is it doesn't have to be. It can be any sort of unique name that you want. And then there's a set of functions you can define that live on this that really define what to do. So if you are used to writing jQuery, this would be like your DOM ready function. When everything's done processing, this is where all your logic goes. So what we found, for example, if we had some code that we go to a page and that page needs to start loading files in the file system, that's an asynchronous operation. We need to grab a handle to that asynchronous operation. So what we would do is at the level of this page, we would store a reference to whatever asynchronous process we kicked off. And then whenever the page was unloaded, we would need to actually cancel that promise. So that's a really simple thing to know, but it's not something that you're used to doing if you haven't worked with these asynchronous APIs before.
How critical is this?
It depends on your app. So the question was, how critical is this? It really depends on what your application is doing, but it's likely to cause you problems for a number of reasons, right? So if you have a scenario where you're doing something like just reading files, like in our case, we were reading files from the picture library, right? So if you go to that page and you start reading files from the picture library, and then the user clicks the back button, and then they go back to that page again, and then they click the back button, and then they go back to the page again, those operations aren't being canceled. They're still taking place, and JavaScript hangs on to the callbacks. So you can end up slowing yourself down significantly. So it's something where if you are doing anything async, I think you should really be aware of it. I think it's probably a best practice out of the box to hang on to your operations and to cancel them explicitly. It's better to do it. It's better to do this than not to do it, would be my advice. So this is a snippet. I'll zoom in on it as well. This is a snippet of some actual code from our Halo.js project where we ran into this problem, and we had to end up implementing a custom promise to fix it. So let me step through this code briefly. So what we were doing specifically was we were getting a number of pictures from the picture library that there's an API that Windows 8 provides to you, the Windows Runtime provides for getting those photographs. And then we needed to process through those and perform some operations, in our case, this new Hilo picture. And that was actually like setting up a view model. One of my other tips we'll get to here in a moment is why we had to have a view model in the first place. But that actually took a little bit of processing time, because when we set up that view model, we actually had to make subsequent calls to get additional information about the file. Okay? So when we wrote it initially, this was a really simple for loop that just got all the files, set up these view models for them. But it blocked the UI for, I think, about 400 milliseconds. So it was very noticeable what it was doing. So we had to rewrite it into using a promise, right? Which is what this return promise is right here. So unfortunately, I missed Chris's talk. I don't know how deep he went into the structure of a promise. I won't spend a lot of time on it here because it is something that's pretty easy to look up. But let me just step through the overall logic. So first, we wanted to get the number of files that we had retrieved from our function. I then wanted to have a place to store those that was going to be the same size of the array as what was passed into us. And then we get our starting position, right? I'm going to move backwards to the array for the same reason that I mentioned before, which is that we don't want to constantly reevaluate the array. And then I have this variable here, this proceed equal true. Now this really is my flag for telling me whether or not we've canceled the operation. Okay. Now I have a function here that is simply setting proceed to false. All right. Now I really did this here just so we would have it explicitly named, so it'd be easier to identify what it was. Let me scroll down a little bit now. Very jumpy mouse. Okay. So this whole little bit of code is actually setting up a promise. We can see here we have internally this process next file function that is inside the promise. Okay. Now we do this because we want to capture some of the state that's taking place and iterate over the files. This logic is a lot like what I showed you earlier, where we're basically grabbing one thing from our array, we're doing some expensive operation on it, then we're decrementing our counter, and then we check to see, hey, have we hit the end of it? If we are, we're going to say that we're done. And this complete function here is something that promises pass into us. It's a function itself that we can call when our promise is done. And then we provided the results that we've constructed so far. So the result of the expensive operation we're stashing back in an array with the same index that we grabbed from, and that's what we return. If, however, that our proceed has been set to false, then we can call the error function cancel. And this is like just something you have to know. It's in the documentation that when you want to cancel the operation, you call the error function passing in a string of cancel. If we haven't canceled it, then we can continue processing the next file. And then, of course, we have to kick off the entire thing by calling process next file once to initiate the whole thing. Now, I hope that you don't have to do this much in your applications because this is a little bit confusing, I think, especially if you're not familiar with asynchronous programming. But this is something I want you to be aware of. This is a problem that you may encounter, and there are known established patterns to solving it, and I think it's good to be somewhat familiar with them. Oh, and I almost omitted. When we create our promise here initially, there's two parameters. There's a function here, which we just have inline defined, and our second parameter is this onCancellation function that I defined just above the fold here that simply set the value to false. So when you define a promise, it takes two functions. Okay. Any questions? I know I'm giving you guys some deep information here that's in little, well, just like a Wonderland, strange, isolated episodes. Any questions before I continue? Okay, there will be more time for questions at the end. The second place that I found that confused a lot of developers was in the area of navigation. So with the WinJS system, you get three major parts sort of out of the box. The first is this namespace, this object, the WinJS navigation. And what it provides to you is really a set of events. So this is part of the Windows library for JavaScript itself. And you can call things on this like navigation.navigate or navigation.back or navigation.forward. And what it does is it just raises events. It doesn't handle those events, though, which is something that I found confused myself and others, seasoned developers. In addition to the navigation object, you also have the pages object, which I showed you a little bit of code from. And the pages object is really for setting up things that will be used when the events are raised, which are these pages, right? Now, what is really confusing is that if you go to Visual Studio and you say File, New Project, and you choose the blank template, you'll get the navigation and you'll get the pages. And if you write some code that says winjs.navigation.navigate and provide a page that you defined, nothing will happen. Just silence. And that's because this guy will raise an event, but there'll be nothing out of the box to handle that event. If you choose one of the other templates, there's a grid template and a navigation template, and I think a fixed layout template, they will include for you this file, navigator.js. And navigator.js is code that we provide. It's part of these new projects that actually will listen to this event. When that event is received, it will find a place in the DOM to go and take the page that you defined and to put to render that page and to put it in the DOM for you. So I asked around because I wanted to know, well, why is this Navigator.js separate? Why isn't it its own thing? And what I was told is that we wanted you guys to be able to have flexibility over how those events are interpreted. If you don't like the way Navigator.js works, you can freely replace that. Whereas we felt the rest of this was fairly generic enough that we could bake it into the system. So that's a very handy thing to know. Make sure I'm not going over my clock. A few other miscellanea regarding WinJS itself. If you look at the Hilo.js project that we built, we actually created an app bar on every page that we built. And after the project was done, I was talking to some people on the app bar team, and they said, you know, really, you can do that, and it's okay. It won't hurt you. It's not critical. But they recommended that for future applications, we use a single app bar for the entire app and just switch commands in and out of it. And I raised that here because this is not something that I gathered from just reading through the documentation. Something else that's kind of interesting, too, is that there's actually a built-in message queue into WinJS. And actually, I think I may have failed to put a code sample here, so let me flip over to Visual Studio for that one to show you what it looks like. So inside, this is actually the source code from our Hilo project, Hilo.js project. And you can do this. So here's a winjs.application.queue event. You can pass in an object literal with a type parameter, and then something that you name. You can make it this name here. We chose to use the convention of naming all of our application events with our namespace, which was the Hilo : And basically, this is a built-in like message bus that you can throw messages on and have other parts of your application listen to. And it's something that we didn't really know about. I mean, it was kind of a surprise. Oh, hey, there's this nice little gem that's sort of hidden there. Will your applications need to use that? Hard to say. Our particular use for it was that we wanted to listen to the file system for changes. Whenever someone modified an image inside the picture library, we wanted to be able to respond to that change, and we wanted that event to be raised independent of whatever page the user was on. We didn't want to care about where they were in the application. So any page that was loaded up in the UI that cared about this could actually subscribe to that event. And I'll show what that looks like. And once it's subscribed, it could handle it in the appropriate way. So here we go. So in this case, we add an event listener in the same sort of standard pattern we use for all JavaScript to add events, and we can pass a function for what we want to happen when that event is raised. Something else that's useful to know is that WinJS comes with data binding, but it's a one-way data binding. So it can only take things that you have as a model and bind them to UI elements. It doesn't bind the other direction. But there is a way for you, if you care to go and write some custom code that will allow you to have bindings back into it. We didn't use this in our project, but I know when I've talked to people about WinJS, this is a question they always ask. And the tip is that if you want to find out about this, look for binding initializers in the documentation. Okay, so now let's talk a few things about the Windows runtime itself. I don't have a lot of material here, but there's a few key ones that really tripped me up. The first thing to know is that objects that originate inside the Windows runtime, they're not JavaScript objects. You may treat them like JavaScript objects, but they won't obey the rules. So for example, if you're used to writing JavaScript, you think, oh, I can slap a property on this object. I can change its state. I can replace things. If it's coming from WinRT, you can't. So one place where this tripped us up a little bit is initially we wanted to write unit tests. And we didn't want to have to take a dependency on the Windows runtime itself, right? So we would take some objects that we would get from the Windows runtime and we would try to replace properties on them, but you can't. There's actually other reasons why that's probably not a good idea. Another place where that actually tripped us up was we also wanted to bind to some things that we were getting from the Windows runtime. And so we would call this function here, this winjs.binding.as, and we would pass in an object we got from WinRT. In our case, it was a storage file, which is the object that we get from creating the file system. However, this guy works by creating a wrapper around the object it receives and attaching that wrapper to the object itself, which means that its target needs to be mutable, but objects we get from WinRT aren't. Which is one reason why, as I stated earlier, we needed a view model for that. And let me show you some of that code. Is that actually legible as it is? I don't have to zoom in, do I? Yeah. So this is a little bit of code here that actually, this is using the Windows runtime, the windows.storage.knownfolders.picturelibrary.create file query. So this is basically saying, hey, WinRT, I want to query the file system. And in this case, we're saying I want to specifically query the pictures library. And then once we have that query, we can say, hey, get me some files, starting with index 0. I want 2 files. Now this right here returns a promise, and we know it returns a promise because we see the then function being called on top of it. So once that's done, we're going to get the results inside this callback. And then you can get specific files by referencing them by index from this array that's returned. So we had this pattern in our application. We then tried to call winjs.binding.as on the storage file we got there, and it didn't work for us. Which meant we couldn't really bind these to the UI if we wanted to change properties on it after the fact. So our solution for that was to create a view model. I use the term a little loosely, actually, and to provide the change notification, the observability in that view model, and then just wrap this guy. Some other things we learned when working with the file system was that you create queries similar to the one I showed you. And what we found was those queries actually behave differently depending on which folder you were targeting, which really confused us, especially when we were writing unit tests. Because we wrote a test that said, OK, here's a query. We expect it to do X, Y, Z. We actually had an integration level test where we passed it a fake folder and expected to get certain results back, and it just didn't work. We got back everything. Nothing was filtered. It really confused us. And it turns out that when you create queries, there's actually a property. I need to, right here. It's in my notes, which I couldn't see before. This are query option supported. So when you have a folder, like our pictures library was a storage folder, there's actually this query option supported method that you can pass in the query options that you have, and it will tell you whether or not the things you've chosen are supported. Now, the real difference tended to be in the areas where some folders were indexed and others were not. So that's the thing to look out for. So, for example, I think Francis mentioned in his talk that there's a few folders that are dedicated for the application. There's a temp folder, there's a roaming data folder, a local folder. They're similar to isolated storage. By default, those guys aren't indexed by Windows. So if you try to query those, the filters that you apply in your query may not work, which really confused us. One little pro tip is that you can actually create a subfolder in those locations that is named indexed, and that will actually get indexed by Windows. So when we would query our picture library, it would work. When we would query one of those local isolated storage folders, the query wouldn't work. Another tip about using the file system is there's actually something called advanced query syntax. Now, I'm curious. Has anybody here heard of advanced query syntax for the file system? So one person. I had never heard of it. It's actually been around since Windows 7. It's basically like a type of SQL for the file system. And it's powerful. It's crazy powerful. But I had never heard of it and didn't know what to do with it when I found it. This is an example of AQS from our Hilo application. You can see what this is actually saying is, hey, I want to get all the files in whatever my folder I'm targeting is that match this query. And this is actually a date range here using the ISO 8601 standard. Another little pro tip here is that when you have a date in JavaScript, actually, let's just demonstrate this. This is worth something. So if you have a date object, right? There we go. Nice date object. There's a method built onto it called toIsoString. And if you call that, it actually gives you, let's zoom in there. It actually gives you this ISO 8601 string. Well, unfortunately, it provides you with the milliseconds, these little 4 digits right here. If you pass that to an AQS query, it fails. It won't understand it. So if you're using JavaScript dates, you have to be aware of these little nuances. I think in this case, too, the Windows is more standards compliant. I think the JavaScript is actually wrong to include those milliseconds, if I recall correctly. And in fact, that was actually something that we ran into in more than one location, was when we were dealing with dates, which, I mean, if you bingle JavaScript dates, you'll find that they're pretty crazy to begin with. But it's even crazier when you start trying to interact with the file system and you're dealing with locality in these queries and whatnot. You can get into some situations. We actually talk about that inside the Hilo JS project. So if that's the scenario you're dealing with, I recommend checking out the guidance there. Another thing that's related to AQS in the file system is this concept of file properties. So I had no idea how much Windows, both Windows 7 and Windows 8, tracks with respect to the file system. It's crazy. There's so much information available. As a matter of fact, here is a list of properties that Windows knows about. And actually, this isn't a whole list. This is only about 3/4 of the list of properties that are classified as system properties. And there's about, I think, 15 other categories of properties too, right? So this is just one segment of one slice of all the properties that are available. And if you go back and look at the query we had here, it's using the system.itemDate property. And that's one of these guys somewhere on this screen. So another thing that we ran into when we were building these applications was really how to structure the applications. So in the opening keynote this morning, the fellow that called Alesh, Kieran Mockford, who was over here, he had one of the first JavaScript apps that was in the store. And if you talk to him about it, one of the things he'll say is that it's really hard to organize big JavaScript applications. In fact, if you look at the JavaScript community right now, this is a hot topic, is how do we go about organizing. If you just do a file new project, what you're going to get is a collection of loose JavaScript files. You'll get some HTML pages, and you'll get references in those HTML pages to the scripts that you want to associate with those pages. And that's fine. That's sort of, I'm calling that the standard historical model. That's the way we're used to building it. And in fact, there's a really valuable benefit to that in Windows 8, which is that Windows 8 will actually analyze those HTML files. It will see what scripts you reference there, and it will cache the bytecode for those scripts, so it'll load faster on subsequent loads. If you actually try to load things dynamically, like load the scripts via code, then Windows 8 won't know about it and it won't do any of the bytecode caching. So there's a compelling reason to use this standard historical approach. However, I started writing a game with JavaScript, and I had lots of files. And it hurt because the order in which I loaded the files mattered, right? So I had in my main HTML, I had lots of files. Actually, let's take a peek at what some of this might look like. Happen to have Visual Studio open right here. Now this is our Hilo.js project. I'm going to go to the default HTML page. And you can see in our traditional model, we have all the JavaScript files manually referenced. And again, this is good because the bytecode caching takes place. The problem with it, though, is you have to manually go in and make sure that when you add a new file to the project that you're referencing it here, right? There's actually some scenarios with the Navigator.js that I mentioned earlier where if you create a page that has a little HTML snippet in JavaScript, it'll load that for you automatically, and you don't have to reference that little bit. But as you can see here, there's still a lot you need to reference generally in the applications you build. When I was writing my game for Windows 8, that really hurt. I just got tired of adding things over and over again. So I started investigating what other options were. And one of the things I found, and this is not the only option, but one of the options is this asynchronous module definition, this AMD. So there's a lot of standards that are being proposed right now in the JavaScript community for how to build modular code, how to take these complex applications and put them together. And AMD is just one of these proposals. There's also something called CommonJS, which is a community-driven effort. Actually, CommonJS defined the standard that we use for promises in WinJS. But CommonJS has a proposal for modules as well. If you've done any Node development, Node is all about modules. They have a very, very mature, I would say at this point, module system. And I've done Node development. I really like that. So that probably influenced my thinking as well. So let me show you what the AMD code looks like. So here is a little snippet from the game I'm writing. And you can see at the very beginning we have this define function here. And this controls the camera in the game I'm writing. So it's camera.js is the name of the file. And we pass into the define function this function that is actually a closure for creating whatever object we're interested in defining. This protects the JavaScript from polluting the global scope. But the function require that we pass in right here enables us to grab other dependencies. And the way this works is those names are actually files that are then located and loaded into those variables, right? So I have another file that's this entities map grid that actually is loaded into this map grid variable. So this is actually a lot like using assemblies in that sense, right? Because it's like a using statement that points to some other thing that we then can load up. Or probably a better analogy is it's really service location. It's an instance of the service location pattern. But I liked this because it meant I didn't have to care about the order in which my files were loaded. So what's the negative for this? Well, when we were doing the Hilo.js project, we voted against doing this. We actually had a lot of discussion about this. It's still on our Codeplex site. But one reason is we were concerned about giving too many concepts to developers at one time. However, I consider you guys to be like the advanced graduate level crowd, so that's why I bring it up here. The other negative thing, though, is that if you look at my default HTML page, you can see that I'm not referencing everything here, which means that the bytecode caching isn't taking place. Now, there are some workarounds for this. If you end up using this sort of model, there's utilities that can be ran that actually concatenate everything into one file, and then you include that in place here. So you can get back to that, but it's not a part of the standard Windows 8 story yet, so I don't want to necessarily encourage you to go out and do that, but I do want you to know that that is an option if you run into the problems of how to manage these large JavaScript applications. And I also wanted to say that this is a new space. I feel like the JavaScript world itself is maturing. It's actually, for better or for worse, addressing a lot of the problems that have already been solved in other languages. So there's always space for something new and magical. There's always room for innovation here, and it's something that I expect to see. I mean, as Alesh said earlier, we're on a journey with Windows 8. I expect to see more growth here from the community as well. This is a blank slide because I wanted to have a moment of awkward silence. Okay. Actually, that was to remind me to show you the demos, which I already showed you. Or not the demos, but the code. So another area that we ran into, I don't want to say problems with it, but it wasn't intuitive necessarily what to do, was in the area of unit tests. So there was a couple of different models we tried out. One model was that, well, first of all, there is no test runner for JavaScript for Windows 8 applications. So if you're writing unit tests for a Windows 8 JavaScript application, you can't go to the Test Explorer and say, run my unit tests. That's not currently possible. So we needed to come up with another way to run our unit tests. The main problem is that you can't access any of the Windows 8 stuff outside of a Windows 8 application, right? So if your tests are integration level tests and you have to touch Windows runtime, you have to be in an app. So that left us with some limited options. The first option was to actually hide our unit tests inside of our code. And we played with that a little bit, and we ended up not liking it, although that could be a viable solution for you. The benefit of it is that the code under test is in the same project as the unit tests itself, so you have to worry about keeping the two things in sync. The negative of it is that you have to have, before you go to production, something that strips your unit tests out of your actual application. The approach we decided to take with Hilo was to have two projects that cross-link the source files. So here I'm back in the Hilo.js project. You can see that the Hilo project itself is our actual application. That's all the source we care to test. And then we created a second project called specifications. Oops, wrong button. That actually had our unit tests in it, which are in the spec folder. Now, the negative of this approach, because it's all about trade-offs, right? Pros and cons, is that we had to make sure that we kept all the files in our Hilo project itself referenced inside the specifications project. We ended up writing a little bit of a script that would do this for us so that we weren't having to constantly add the files in both locations. But those are your choices. So what this means is that when we want to run the unit tests, we actually have to make this the application that we're running, and it launches as a Windows Store app itself and runs through our unit tests. What I found personally was that when you have two monitors, this was awesome. Because I'd have one monitor up with the Windows Store app running my unit tests, other monitor with Visual Studio. There's a keystroke, Control-Shift-R, that refreshed the app the same way a browser would be refreshed with F5. And I could write my tests, hit the keystroke, and I would get immediate feedback in my test runner. If you don't have two monitors, it might not be as smooth a process for you. I also wanted to mention that there are some... there's lots of options for running your unit tests. I know that there's Chutzpah, which is available on Codeplex, and I believe they have some Windows 8 specific work they're doing. I haven't actually looked into it yet, but some other people have told me that it's good. So if that's this is actually a test running framework that's different from a test specification framework. What I mean by that is it still uses something else called Jasmine to actually write your unit tests. This is more for how to execute those inside Visual Studio. For the Hilo project we actually use a test framework called Mocha, which is lesser known in the client-side browser world. It's more of a Node.js. But the reason why we used it is because it had a very nice syntax for defining asynchronous tests. And if there are fans of Jasmine in the room, we did consider Jasmine, but there was a little bit of friction with Jasmine and asynchronous tests, which is why we went with Mocha. And we talk about that a little bit, I think, in the guidance that we have. And that is all the content I actually have. 2 links for you. It was first the link to the project, hilojs.coplex.com. I think, though, it's on the code gallery now. Is that correct, Blaine?
Yes.
So it's also on the code gallery, the actual Dev Center code gallery. You can look for it there by the name Hilo.js. I also want to point you guys to a resource that I just recently learned about. There's a fellow that works for Barnes & Noble who's building Windows 8 applications in JavaScript and who's talking about it a lot. And he's created a set of modules for helping to build Windows 8 applications called Winning.js that looked really good, looked really interesting. So I wanted to put those out there. So at this point, I'm going to stop and let you guys ask questions. I hope you have lots and lots of questions. So, or maybe one question. Yes?
So when you're operating in the browser, you have like the global context, which is the window. What is kind of the global context when you're developing?
Okay. So the question was, when you're operating the browser, you have a global object, which is the window that everything is attached to. And the question is, when you're building a Windows Store application, what do you have? And the answer is actually, you have the same object. You actually have a window object that works the same way it works inside the browser. You just have some additional objects that are attached to it that are reference points for these APIs. So you can still do things like window dot location inside a Windows Store app. It may not, that particular API may not be as meaningful, depending. But what you have is you have window.windows, which is your global object for the Windows runtime APIs, which you can also just omit the window dot and just say Windows. And the same thing is true for WinJS. You have WinJS as a top level, well, as a property in the top level global object. Yeah, pretty much anything you can do in the browser with JavaScript, you can do in a Windows 8 application. I say pretty much. I think there's actually an article in the documentation describing a handful of scenarios that are not allowed, which have to do mostly with getting code from unknown sources. But pretty much anything you want to do that you're used to doing in a browser, you can do. Other questions? Yes?
What would you use as your selling points when pitching JavaScript as the choice for implementing a Windows 8 application?
Okay. Yeah, so the question is, why would we choose, or why would I sell JavaScript over C# XAML or C++ XAML? This is actually a question that we write a little bit about in our guidance for our project. As in all good software development, the answer is always it depends, right? So I don't think there's necessarily a cut and dry answer. I would ask questions like this, though. What skills does your team currently have? If they have JavaScript HTML5 skills, then I would leverage those. If they have C# XAML, I would go with C# XAML. The other questions I might ask are, what sort of applications are you building in addition? So I actually think there were some types of games, for example, that might be better using the Canvas APIs right now than they would be in the XAML space. Or, on the same time, if you're doing some heavy DirectX stuff, you obviously don't want to be in the JavaScript world. There are a few places. So we've worked really hard to make sure there's parity between the platforms so that you don't have to choose one platform over the other because of the features that are available for it. But there's a handful of places where there's some slight differences in what controls are available. And I'm drawing a blank, but I know there was one control that was available for JavaScript that wasn't available for it. But I think the big answer overall would be, what is your existing skill set? And align it with that. I can say personally, too, that I love C# and I love JavaScript, so it's kind of hard for me. I bounce back and forth a lot. Well, yeah. Does that answer your question, though?